You know, gold, for thousands of years, we've seen it as this ultimate symbol of wealth and power. But its real story? Oh, it's so much bigger than that. It's more violent, more cosmic than you could possibly imagine. So today, we're going to trace it back to its incredible, fiery birth.
So let's just jump right in. Think about a gold ring or any piece of gold jewelry. Have you ever really stopped to think about where it came from? And I don't mean from a mine or even from deep inside the earth. I mean, where were those atoms, the actual building blocks of that gold, first created?
Okay, get this. The answer is it wasn't made here. Not a single atom of it. Every bit of gold on this planet is, for all intents and purposes, alien. It's an immigrant from some insane cataclysmic event that went down in deep space way, way before our planet was even a thing.
Which brings us to gold's truly mysterious cosmic origin. It's wild to think about, but when you hold a piece of gold, you're literally holding a fossil from an ancient, violent, cosmic event. It's history, right in your hand.
Yeah, those tiny atoms in that ring, they were forged in this unbelievable cosmic explosion. Then they traveled for who knows how long across the vast emptiness of space. Eventually, they got swept up in the huge cloud of gas and dust that would become our sun, our planets, and us. So yeah, gold is quite literally stardust.
Okay, so if gold comes from space, your first guess would probably be a star, right? I mean, that makes sense. Stars are the universe's giant element factories. But here's the twist. Even these incredible stellar forges, they have their limits.
This whole process has a fancy name, stellar nucleosynthesis. But really, you can just think of it as the engine that makes the universe go. Deep inside stars, the heat and pressure are so intense that they literally smash lighter elements together to create heavier ones. It's how we get things like carbon and oxygen, the stuff we're made of.
So, a star starts with the most basic stuff, hydrogen, and squishes it into helium. Then it takes that helium and makes carbon. And it just keeps going like that, climbing up the periodic table, building bigger and bigger atoms. But it can't go on forever. The process hits a wall, a really, really heavy wall made of iron.
And here's the absolute kicker. Fusing anything up to iron releases energy, which is what keeps the star alive. But trying to fuse iron, that actually sucks energy in. It's like a black hole for energy. For a star, that's game over. The furnace just shuts down. So even the biggest, baddest stars that go supernova can't make gold or silver or platinum. So if they can't do it, what can? We need something way, way more extreme.
And that brings us to the answer. The universe's ultimate gold factory isn't in a living star, but in the collision of dead ones. We are talking about one of the most violent, mind-bending events in the entire cosmos, a neutron-star merger.
So what in the world is a neutron star? Well, imagine a giant star dies in a supernova explosion. All its outer layers get blasted into space, but the core collapses in on itself with so much gravity that it crushes everything. Protons and electrons get mashed together to become neutrons, creating something so dense it's almost impossible to wrap your head around.
Okay, to really get a picture of this, let's try a thought experiment. Take about 1.5 times the entire mass of our sun.
And now, squeeze all of that, every last bit of it, into a ball that's only about 20 kilometers, that's like 12 miles, across. You're talking about the mass of a whole star packed into the size of a city. It is absolutely insane.
I mean, the density is just absurd. There's this famous analogy that really drives it home. A single teaspoon of neutron star stuff would weigh billions of tons here on Earth. Billions. It's just wow.
Now, here's where it gets really interesting. Sometimes you get two of these cosmic zombies orbiting each other in a death dance. As they circle, they send out ripples in space-time, gravitational waves, which makes them lose energy and spiral closer and closer and closer until, bam, they collide in an explosion so powerful it shakes the very fabric of the universe.
For the longest time, this was all just an incredible theory. But then, thanks to the James Webb Space Telescope, we actually got to see it. We caught them in the act. This is where Webb makes its golden discovery.
This right here, this is one of the coolest moments in the history of astronomy. Check this out. On August 17, 2017, our gravitational wave detectors, LIGO and Virgo, felt a shake in spacetime. Then, just 1.7 seconds later,
Bam! A gamma-ray telescope saw a flash of high-energy light from the exact same spot. And then, 11 hours later, telescopes all over the world pointed to that spot and saw a brand new flash of light, a so-called kilonova. It was perfect. We saw it, we heard it, and we felt it across the cosmos.
So this kilonova, it's the afterglow of the collision. The crash throws out this huge cloud of material that's basically a super dense soup of neutrons. And in that chaotic mess, this incredible thing happens called the R process. Basically, existing atoms get absolutely peppered with neutrons so fast that they don't have time to fall apart. They just get bigger and bigger, creating all the heaviest elements like gold in a matter of seconds.
This is where our hero, the James Webb Space Telescope, comes in. It's so powerful, it can stare at the fading light of these kilonovae and basically read the ingredients list. It can see the chemical fingerprints of all the new elements being born in that explosion. And you gotta love the irony here. Webb's giant mirrors are coated in a thin layer of gold to make them better at seeing infrared light. So literally, it took gold to find gold. How cool is that?
And with a more recent explosion, Webb gave us the smoking gun. Eleonora Troja, the astrophysicist leading the team, said it all. This is the first time we've been able to verify that metals heavier than iron and silver were freshly made in front of us. Think about that. This wasn't some abstract theory anymore. We were literally watching the universe forge heavy metals in real time.
So let's wrap our heads around this. This isn't just a cool space fact. It completely changes how we see the most precious things on our own planet. They weren't just found, they were forged in cosmic fire.
So the big takeaway here is pretty profound. The stuff we consider most precious, gold, platinum, it isn't made in the calm, steady glow of a star's life. No, it's created in the most violent, the most chaotic, the rarest moments the universe ever experiences. It's the beautiful, glittering ash left over from a cosmic car crash.
So really, the next time you see a piece of gold, just take a second to think about its insane backstory. That metal was born in the collision of two dead stars, a brilliant flash of creation lighting up a cosmic graveyard. It really makes you wonder, right? What other incredible secrets are hiding in the starlight, just waiting for us to figure them out?
If you want to keep diving into huge cosmic questions like this one, make sure you subscribe to Space Repo. We've got plenty more to explore. Thanks for joining me on this one.